All right, so starting for chapter 5, we're going to be working on factors and multiples. Our lesson objectives for at least the first 5 or 6 lessons is we're going to work on finding all factor pairs for a whole number in the range of 1 to 100, which basically means we're not going to find factor pairs for any numbers over 100. We're going to be able to recognize that a whole number is a multiple of each of its factors, and then determine whether a given whole number in the range of 1 to 100 is a multiple of a given one-digit number. Alright, so I found this cool little video and song. Hopefully you guys will like it, and you'll rewatch it enough times so that you can memorize what factors and multiples are. Hope you like it.
So turn it up. Multiply, multiple. Multiply, multiples. Higher, go higher, go higher, go higher. We break down the factors. They're lower, go lower, go lower, go lower. Multiply, multiples. Higher, go higher, go higher, go higher. We break down the factors. They're lower, go lower, go lower, go lower. Alright, listen up. Well, Master is here to straighten up your math skills. Don't fear. I know I wasn't born a rat, but I love everything about math. And math has multiples that we have to find. Multiples are easy if you try. You start with a number and keep going higher, just like counting by equal multipliers, like 3, 6, 9, 12, and on. Multiples of 3, they go on into eternity. Multiply, multiples. Higher, go higher, go higher, go higher. We break down the factors. There's lower, go lower, go lower, go lower. We multiply, multiples. Higher, go higher, go higher, go higher. We break down the factors. There's lower, go lower, go lower, go lower. Now on to factors we can't let pass us. The bit inside, let's divide like masters. Talk about the factors of 10. 1, 2, 5, and 10 again. There's a limit to the numbers that go inside. Use the rules, better recognize. Every single number has at least 2. 1 in itself, easy to do. Don't be fooled when the factors aren't plenty. If there's only 2, it's a prime. Do you hear me? I know you do, don't pretend like you don't. If you only use your brain, composite is an easy thing. It's a number that has more than 2. Factors on the inside, what's it to you? Once you break it down, factors are easy. Don't get queasy. Now dance with me. Multiply, multiples. Higher, go higher, go higher, go higher. We break down the factors. They're lower, go lower, go lower, go lower. We multiply, multiples. Higher, go higher, go higher, go higher. We break down the factors. They're lower, go lower, go lower, go lower. One, two, 5, and 10 again. There's a limit to the number that go inside. Use the rules better recognize. Every single number has at least 2. 1.
Alright, hope you guys liked that. Miss Fernley did. Me and Lily and Tina were dancing around yesterday. Alright, okay. So we are going to use grid paper. So you should have taken grid paper home with you today. And we're going to be using that to figure out factors, the factors of 24. Okay, so there's a lot of different ways that you can multiply to get to 24. So the most obvious one is 1 times 24, right? So I'm going to do one column and I'm going to count over 1, 2, 3, 4, 5, 6, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Okay. So this would be my model of 1 times 24. Okay, what is another way that we can do 24? Well, 24 is an even number, so we can actually go 2. So if I did 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. That would be my model of 2 times 12. Okay, so there's another one. 2 times 12. What would another one be? How about 3? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. And so that is 3 times 1, 2, 3, 4, 5, 6, 7, 8. So there's another. Okay, let's see, what else can we do? We can do 4, right? Let's do 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So this will be the model of 4 times 6. Okay, and I don't think we can go any further than that because I think we have them all set up already. So the factors of 24 are all these numbers. So it's 1, 2, 3, 4, and then what they multiply by. So 24, 12, 8, and 6. And those are all the factors that are listed for finding the factors of 24. Okay, so here's another example. We're going to use the arrays. That's what this square is, or that's when we draw squares on the grid paper. That is called an array. Okay, and to name the factors of 12. So I'm going to go with the most obvious, which is 1 times 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So one row of 12 boxes. So that's 1 times 12. Okay, and then I'm going to go 2, because 12 is an even number, so I can do it by 2s. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And that is 2 times 6. I know I can go 3s. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 3 times 4. Okay, is there any other ways to make 12? No, 5, 6s is there, 7 won't, 8 won't, 9 won't, 10 won't, 11 won't, and then we get to 12. So there are no more ways to name the factors of 12. So my factors of 12 are 1, 2, 3, 4, 6, and 12. And these things are called factor pairs. So when it asks you in your homework or on a test what the factor pairs are, that is these actual multiplication problems. A pair is 2 numbers. Okay, so it'd be 1 times 12 would be a factor pair. All right, here's another one, finding the factors of 5. Okay, so finding the factors of 5. Obviously, I can do the 1, 1, 2, 3, 4, 5, so 1 times 5. But is there any other way? I can't divide by 2. I can't divide by 3. And I can't divide by 4, and 5 is already there. So the only factors of 5 are 1 and 5. All right, so on this one, it's asking me to find the factors of 20 and then list the factor pairs. Now, if I'm drawing my boxes, I should be listing my factor pairs already. So we'll go through and do that together. So the first thing you do is go ahead and do the number 1. So it'll be 1 times 20. So count out 20 boxes with me. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, so it goes all the way across my grid paper. So 1 times 20. I drew my box. Okay, and I'm going to list my factor pair, which is 1 times 20. Okay, now I can do 2. So we're going to do 2 rows. So I'm going to count them. 1, 2, all the way to 20. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, so there is my array for 20. And that would be 2 times, and I would count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, let's see. How about 3? Can I go 3s? 3 divided by 20. If I'm not sure, I can always try, right? I can go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. That would give me a box that looks like this. Is that a square box? Then it can't be divided evenly. Okay, so 3 doesn't work. 4, let's try 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. That works. Makes a square for me, or almost a square. Okay, so that would be 4. 4 times 5. 6, we can try 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Does that make an even number? No, it does not. So 6 doesn't work. I'm assuming 7, 8 doesn't work. 9 doesn't work. And 10 doesn't work. What about between 10 and 20? Does anything else go? Nope, I believe these are my only ones. So these are my factor pairs. So I already list my factor pairs. And now I need to list my actual factors. What are my actual factors? Factors are only one number. So it would be my 1, my 2, my 4, my 5, my 10, and my 20. All right, here's another example, 25. Go ahead and start with 1, because that's the most obvious. 1 times 25, which I don't even think I have enough space. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. We'll pretend there's boxes down here. So that would be my 1 times 25. Okay, can I go 2 into 25? Well, 25 is not an even number, so it's not divisible by 2. I don't think anything times 3 is 25. 4 times 5 is 20, and then 4 times 6 is 24, so it can't be 4. But I do know that 5 times 5 is 25, so I can go 5s. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. That gives me a square, and that works. So it'll be 5 times 5 is 25, and that is all for my 25. So these are my factor pairs. And then my factors would be 1, 5, and 25. Now, why don't you have 2 5s here? Because you got 2 5s here. You don't need to list them twice, because this 1 5 counts for both of them. Okay. Only list the numbers one time if it's 5 times 5 or 6 times 6 or whatever the case may be. All right, so this is your homework for tonight. We'll do a couple of problems together, and you'll do the rest on your own. So it's asking me to record the arrays on grid paper and write the factors as shown. So let's do a couple of the odds together. So 45. Oh, let's do a dual screen here so we can do them together. All right, so 45. I don't know if I can go 45 across, but we're going to give it a shot. So we'll start off with 1 times 45. So one row, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45. So we'll pretend that goes out like that. And that is my 1 times 45. Okay, what else can I do? Can I do 2s? Well, 45 is not an even number, so I can't divide it by 2. 3s, maybe? We can try 3s. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45. Gives me an even number, so that can be done. So it's 3 times 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 3 times 15 is 45. 4 does not go in. I don't think anything times 4 goes 45. 5 does though. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45. And that should be 5 times 9. Okay, 6 doesn't go in, 7 doesn't go in, 8 doesn't go in, and 9 goes in. Okay, we don't need to rewrite it. 9 times 5, it's already here because of multiplication property says that we can flip-flop them. And I don't think anything else will go in evenly. So I do believe that that is our choices for that. So my factors then would be 1, 3, 5, 9, 15, and 45. Okay, let's do number 5, which is 40. Okay, I can count across here. These are 40 because I counted them earlier. So I know 1 times 40. 2 works also. So I can use my division problems, right? If I do 4, what's 4 divided by 2, which is 2, and then add a 0, okay? So it'll be 2 times 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So that would be my array for 2 times 20. 3. Can 3 go into 40? No, it cannot. 4 can. 4 times 10. That'd be 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so 4 times 10 can go. 5 can go in, right? Because it ends with a 0. So 5 can go in. 1, 2, 3, 4, 5 times 8. 2, 3, 4, 5, 6, 7, 8. Okay. And if I'm correct, that is as many as we can get. So my factors then would be 1, 2, 4, 5, 8, 10, 20, and 40. All right, number 7, 22. And this is our last one. The rest you can do on your own. So 22, 1, 2, 3, 4. We can go 1 times 22, which is going to be right here. Okay, I know I can go 1 times 22. 2 times 11 gives me 22. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And I think that is it. I think that's all I can go with 22. Nothing else goes in. So my factors then would be 1, 2, 11, and 22. All right, so you can do the rest of them on your own. If you have any questions, please make sure you circle them and ask me tomorrow morning. Your WSQ for tonight is use your graph paper to find the factors of these following numbers: 9, 21, 17, and 18. Make sure you're going to turn that in tomorrow. Label it WSQ, and we'll see you in the morning.